Concrete is the most used material in the entire world, second only to water. As a result of that, it also ends up being a significant contributor to global CO2. So some of the things we're doing here in our lab focus on reducing that carbon footprint of concrete and increasing the durability of the concrete, those two things often going hand in hand. So we're working to make concrete last longer and be greener so that we can continue to support all of the infrastructure that's necessary for mankind. Roads, bridges, water pipes that bring us our water and take the waste away from buildings, dams that hold water back and generate electricity. Concrete is really everywhere and necessary for our current way of life. The largest portion of the carbon footprint of concrete actually comes from the cement component of the concrete. The cement is the binder, but it's only one of the ingredients of a concrete mix. The ingredients of a concrete mix are cement, which is a powder and a binder, sort of similar to the flour that we use in cookies. And the other ingredients of concrete are water, and then small rocks, sand, and large rocks, coarse aggregate. Those together create the concrete that we've come to know and love. So you can see the mixture of the materials in this, and it's even more evident on the back. We have a sample name here, but you can see the coarse aggregate intermixed with all of the binder. We're not going to stop using concrete, so we really need to think about how to decrease its carbon footprint. There's a couple different ways that we're doing that here in our lab. One is investigation of alternative forms of binders that have less calcium content and thus less embodied CO2. So we're looking at alternatives that may or may not have been used for the last few decades or may be totally new. They often have completely different properties to our traditional Portland cement. They may set faster, they may have different durability compared to Portland cement. So we're working to both formulate new materials and test and understand how to use them to create similar types of concrete that perform better than existing systems. The other approach that we're taking to reduce the carbon footprint of concrete is increased utilization of something called a supplementary cementitious material. So this is a material, often an industrial byproduct. For example, fly ash comes from the burning of coal. That's what's left over after you burn the coal and extract the heat from it to power our electric generators. Or another industrial byproduct we use a lot is blast furnace slag coming from the steel production process. So both of those materials are wastes of those industries, and by incorporating the industrial byproducts, we are not only reducing the carbon footprint of the concrete, but also increasing the strength and increasing the durability of the material. There's a huge amount of fly ash that's stored in ponds and landfills throughout the countryside of Ohio. So we're working with the Ohio Coal Development Office to understand how that fly ash differs from traditional fly ashes and how we can use it efficiently in our concrete.